And we've done a lot of work using GIS for land use modeling. So, for example, we have worked on predicting urban growth, predicting land use transitions. We have models that users can use to control parameters, control initial conditions, but expert users, that is, experts who understand the models and understand how they work. So here, for example, is the work of Keith Clark, my colleague at Santa Barbara, forecasting the development of the Santa Barbara area under various growth scenarios. A simple model, it's actually a cellular automaton that is based on simple variables such as existing land use, elevation, slope, and access to transport. Here's a model from British Columbia, from the Lower Fraser Basin, the Quest model. This is much more geared towards public participation because the public is able to modify the parameters through a simple interface and then see the consequences in terms of predicted growth in the Fraser Basin. So these are things we can do. But to come back to my earlier point, these are not integrated with the other side of the yin and yang. They're not integrated with sketch and record. They don't allow the non-expert user to participate in the design process. What they do, however, is something that I think is very much a part of this discussion and something that in many ways captures what I visualize as the future of this technology. What I would like is to be able to bring up a map such as this, to design by introducing sketched features, and then to press a button and have that button evaluate or predict or improve on my design by bringing the strength of GIS and all the models that we have available and all the scientific knowledge that we have to assess, model, and analyze my suggested solution. That's something that I think is all too often missing. It's something that we can conceive of doing, given the strength of GIS in the background. So that's why I think this yin and yang is a very appropriate way to frame this discussion and to think about it. Just a few other topics I should mention briefly. One is devices, because I think part of this vision is that these solutions would be interactive. This would be an interactive technology. It might use physical analogs, and I'm sure we will see over the next couple of days physical analogs, including that table. I know, for example, the work of Helena Midasova's group, which has involved the concept of moving clay in a virtual environment, actually shifting clay around, shifting various kinds of physical analogs around in a virtual environment. We can think of this as high-end and low-end. We can think of the high-end as being virtual cave environments or tables. We can think of the low-end as being nothing more than cell phones and Wii terminals. So a huge variety of possible devices might be used to implement this kind of vision. So here's just one example. This is actually the work of Antonio Camara's group at the University of Lisbon. And this involves a table and virtual features are being moved on the table. To go back to my vision, what I would like to see in a table like this is a set of buttons that I can press to bring all of the tools and all of the power of GIS and scientific knowledge to bear on assessing, analyzing, and modeling my proposed solution. And then another element that I'd suggest is something we have to include in this discussion is the wisdom of the crowd. We have to think about this not just in the sense of a top-down process involving experts, but also a bottom-up process involving millions of potential stakeholders. And that's something that these days we can achieve. We have the crowdsourcing technologies. We have Web 2.0. We have mobile phones. This is the world of neo-geography. And if you haven't come across that term before, it's a wonderful term. It refers to the ability of the average citizen these days to do many of the things that geographers have traditionally regarded as their professional expertise. It makes me a paleogeographer, which is a wonderful thing to think about. I don't know if you've seen anything of the MIT, the winning, the competition that DARPA ran a couple of weeks ago that MIT won. Which involved crowdsourcing to solve the problem of finding a series of red balloons located across the United States. And MIT's solution was simply to very rapidly recruit a network of people, a network of observers across the country, and to use the crowd to solve the problem. It's a very elegant kind of solution. I'd suggest that's part of what we have to talk about here, the possibility that today's technology can include a vast array of potential stakeholders. So to try to pull this together, let me ask the question, where do we stand? And I'd suggest that we have currently some of the tools needed to achieve this vision. Some of them are integrated in GIS, but they are generally scattered. And generally they're not integrated with the other side of the equation, with Sketch, with crowdsourcing. They're not integrated with the kinds of participation that we can now achieve through interactive devices. And what's more, the set is not complete. There are some major holes, major gaps in the set. So I think these are the kinds of questions we ought to be thinking about. We have some devices, but the interoperability between those devices is very limited. People who've worked with things like tables have typically developed their own software unique to that device and have not integrated across a variety of different devices. And we have very few studies of how users react to these kinds of technologies, what kinds of design criteria they want to see implemented to make the interaction as easy as possible. So what needs to be done? Here's my suggested set of ideas for what we can talk about in more detail over the next couple of days. Number one, I think it's important that we try to map out all of the use cases. It's easy to become focused on some limited problems of design. And I think we need to keep our horizon very wide and try to think of all the different kinds of design problems that we will face, particularly in the context of Tom Fisher's talk, which raised a host of design issues. And somehow I think we need to enumerate what those are. Number two, I think it would be impossible to approach this problem holistically. The set of possible problems is so large, it will be very difficult to be wise enough to design something to respond to all of them. So I'd suggest the strategy we need to use is a strategy of rapid prototyping. We need to select a few problems and prototype what our vision means for those problems. We need also, I think, to integrate new kinds of user interaction. This means Sketch, this means new kinds of devices, and this means Web 2.0 kinds of concepts. We need to learn from those prototypes, and I'd suggest we need to learn from those prototypes particularly in the sense of the reactions of users. It's the ability of users to interact with these technologies which is going to determine ultimately whether they get adopted and whether they get used. So that has to be an important part of the agenda. And out of this, I'd suggest that we can hope that a comprehensive solution will emerge. I don't think a comprehensive solution should be designed top-down. I think it's too early to see the wood for the trees. So thank you very much for your attention.